Roz. He's the CEO of CodeFresh.
Okay, so I'll tell you first a little bit about myself. I've been in the US for almost 10 years. As you can tell, I'm not from here originally. I'm from Israel. I was relocated here from a company named Mercury Interactive, which was acquired by Hewlett Packard. It happened around 11 years ago. Basically, I was an engineer most of the time, built testing tools, performance testing tools, functional testing tools, and moved here. My experience is predominantly in the enterprise software. I was an engineer, then I was product manager. Then I think, as you mentioned, while I was a product manager in HP, I've seen big changes going on, especially around microservices. I think it was mentioned here before. And the other disruption was around containers. So how many of you have heard about the concept of containers in Docker? Cool. Excellent. Just a feelers, because on the way here I wasn't sure what's the level of familiarity with continuous integrations, containers, microservices, and so on. So for the session today, I brought different slides. If there are things that you already know and you want me to skip and move faster, I can. We can keep it very dynamic. I can talk a little bit more on areas that are more an interest for you. But basically, this disruption are changing a lot in the way that we building, testing, and deploying application. So back in the HP days, I wanted to do it under constraint of HP. Initially, it was funded, but then what happens, and many of you have been in large organization, every 2 months there is a new big manager coming in who has a new strategy in mind, which is different than the manager that was there before, and decided to shift resources to legacy products. I felt too passionate about what I want to do. I left HP almost 2.5 years ago. Founded CodeFresh. We raised money in the Silicon Valley. So the company is based out of Mountain View in the Silicon Valley, and the engineering is in Israel. We're small, but we're already globally distributed. And yeah, so we went live middle of last year. We now being in DockerCon, we partner of Docker. If you're familiar with that. And basically, what I want to talk about today is talk a little bit about continuous integration, just so all of us are on the same page. What it is, what it means, why we need it, what are the type of testing, then how it changed over the time, and then what actually containers and microservices allows us to improve in our dev practices. Feel free to stop me at any point of time with any questions you have. Sounds good? Okay, so I think I have shared enough about myself. That's my Twitter handle. I'm also giving a talk as part of a Containers 101, which is one of the meetups, which is both in-person and online meetup. It's a meetup we have especially to talk about emerging technologies related to containers, whether it's the Docker engine itself, or whether it's orchestration platforms like Kubernetes or Mesos or Docker Swarm, if you're familiar with this type of technologies. So that's the meetup. As far as what CodeFresh is doing, so in a nutshell, and I'm going to give a demo in the end of the session, so just a promo. We basically automate the whole process of building a Docker image, running it through all of the different tests, and then automate the deployment of it to your production. And again, that's in a nutshell. I will show you what actually it does and why containers enable us to do it much faster. So what is continuous integration? This is from the Wikipedia. It basically says that continuous integration is the process of taking the code or the code changes that developer engineers are working and integrating it back to the main branch. So if we have, are you all familiar with the concept of Git and Git flow, the source code? Yeah? Okay. So if we have, usually the way it works with Git, there is a branch, sometimes it's called master, sometimes it's called develop, which represents what's the application in production. And then once the developer is getting their task or something that he needs to implement, he branch out of it, create his own branch in which he's working on this branch to develop the feature or the task that was assigned to him. And as it goes along, there are changes that happen to this branch and there are changes that happen to the main branch during the same time. At one point of time, when he thinks that his feature is ready, he's making, in many cases, they just call it PR. But PR stands for pull request, which means I think my code changes are ready to be merged into the production. And we're going to talk about all the different steps, but then once this pull request has been accepted, actually his code changes are being merged back to the main branch, and in a continuous delivery setup, these changes are going to be automatically being pushed to production. So that's from the flow itself. Any questions about that? Now, this usually continuous integration where it matters when organizations are actually working in agile methodologies. Familiar with agile, Scrum, Kanban? So when they're working with agile, we continually want to push changes to production. It's also mainly relevant if you are working in a team, and it gets more complicated as the team is larger because there are multiple branches running at the same time. So the image that I'm showing here is pretty simplified to one developer, but obviously think about you have multiple developers and engineers at the same time, so there are multiple feature branches. There is also what I'm going to be sharing about as we work in microservices. There are dependencies between this branch to other branches in the application. As our applications are likely to have more than one service. So how many are you familiar with the concept of microservices? Should I? Okay. So what are
It
the...
may be good to maybe just a quick second on microservices.
Okay. So I'll share a little bit about why microservices and why it's picking up. Basically, there was a long time in which monolithic application, client server, were the most common way of developing application. It was very simple on one end. There is one big executable, but it was very difficult when you start working and your team is growing and you want to introduce changes to multiple parts of the application. In order to really make it easier to introduce changes to the application, the concept of microservices came in, with saying I can break my application into multiple services. One service can be the API service, the other one can be the web service. Then when I have them all breaking up, I can introduce changes individually to each one of these services without making changes for the whole application. So to some level, I can have teams working on one service and the other one working on the other service, and I can basically allow them to work in parallel in a much more efficient manner. And that's conceptually the concept. That's conceptually what is microservices. The reason it's working very well with Docker, I'll explain a little bit more about Docker later on and why it's working very well with microservices. But this is, in a high level, the concept of microservices. Our backend is consumed of multiple services, all interacting with each other, allowing teams to work on different services in the same time. So we talked about, merging these pull requests back into the main branch. Now, what are the type of testings or validations that we want to run on these pull requests before we merging it? It's quite an inclusive list, and it will be interesting to see how, sometimes to check how many of these lists you're actually doing yourself, because, I'm meeting with a lot of companies. Some are actually having just code review. Some actually have also unit test. Not everyone has integration test or UI test. But basically, if I'm going to go over this inclusive list, the first one that we have to check is actually that the code can be merged. Sometimes if the same file is being changed by a few engineers, you need to test if the code can be merged. Then if the code being merged, obviously there is a process of code review. We have a peer on our team that is reviewing the code changes and see if there is nothing that look odd in the implementation of the feature. Then the concept of unit test is coming in. Familiar with unit test? So the unit test, but unit test is very basic. It's running as part of the build, just checking that the function, the unit itself that we built. Integration test comes when our application has multiple pieces in it. So we want to make sure that the changes that we make to one piece does not break the process that we have that is going across multiple services. UI test, that's where actually, we can even expand that to both UI functional test and user experience test that sometimes takes in the same time. But that basically can be either manual or automated. There are automated tools like Selenium that you can create scripts that will test the UI of the application, and sometimes the UI testing will actually happen manually in the QA lab by QA engineers. Performance test, so the various of performance tools out there, some I've built myself, some are open source like JMeter and others. Basically the intention is to see that we're not compromising on the performance of the application, and when the application is going to be running in production, we will be able to support the number of concurrent users we've initially built the application for. Lastly, which is tend to be neglected in most organizations till something bad happens, is the security and vulnerability test of the application and the code changes. Security can be tested in different level of the application, whether it's through static code analysis, through vulnerability scanning of the application, and so on. But it's another set of testing that we're doing in order to kosherize, to kosherize the pull request and make it ready for merge. Any question on this?
How would you encapsulate in a microservice environment like testing the APIs, for example, of the service? Would that be part of integration test?
So yes, as part of, and that's in fact one of the things that I will actually demo as part of it, because sometimes even for unit tests, you need more than one component. You need, let's say, your web server and a MongoDB or something else. For integration, you might need additional. So you need to find a way to model the application so you can spin up all the other services to run integration tests, to run UI tests, and so on. I'll talk about it in detail. Okay, so what are the deliverables? And here I'm actually talking about the handshake between the development to the production, to the operation side of the house. Usually once the development ended and we're passing what we're passing to the operations, the typical handshake and deliverables are before containers, and I'm going to get into what is it in the era of containers, was the code base. We're basically giving them a label or a branch. That's what we want to provision in production. We're also giving a report of the test results. This is all the tests that we're running on this code base, whether it's pass, fail. We're also telling them, in case it's not only code, what are the proposed changes to the database, if changes happen to the data in the same time. And we also inform the operations about known issues. So there are certain issues that we know we found elements to fix, but this needs to be known. So these are the common deliverables for continuous integration. Again, everything here is before the era of containers and microservices. I'm going to share how it's actually being done now. And then the common implementation of these different tests across the lifecycle is that they're actually being spread in the lifecycle to the deployment to production. One of the main reasons they're being spread is there's certain tests that can run only when my code changes is running together with all the other components. If I want to do integration tests, or if I want to do UI tests, and I need everything else to run as well, I need these tests can take only at the later phase of the code changes. So if I'm looking here, and I show you a little bit what I mean by here, there's different stages of how you promote your code changes. The code is where I'm still running on my own feature branch. Here it's very easy to run code review, ask people to look at my code and give me comments. Once I'm committing my changes, then the build system can actually verify the unit test and see if everything is working on my own unit. But then in order to test my code and how it works with all the other services and all the other components, Then there used to be staging. How many of you running staging environment? So staging environment is a common practice to actually have the code deployed before being pushed to production and then running additional tests. Staging, the intention is for it to emulate as much as possible or create as much as possible environment that is close to production and then running various of tests on the code there. So running integration tests, UI tests, and so on. So this is the common implementation, and I'm going to share with you now what are typical challenges that we have with this implementation and with continuous integration. But before that, any question on this?
Where would you put like a dev environment? Would that be synonymous with build, so you want to actually have a dev before staging?
The dev environment, like my own dev on my Mac or on my development station, or?
I've been in environments where you've taken a dev environment, which is the Wild West, and depending on what you're doing, it may require, let's put it this way, more infrastructure to do a complete test because it can't be done necessarily, let's say, on a developer's laptop. So there's a certain amount of volatility in that environment, but it's also sort of a good quick check before staging to catch kind of
Exactly.
Obvious bugs, let's say, or shortcomings.
Exactly. So this is what's the recommended way to do it. And in fact, part of the challenges in here is that, in fact, in this time of implementation, you pushing some of the tests to the later phase, which can create bottlenecks. And what containers actually allows you to do is to instantly spin up the environment, dev environment, much earlier and screen for breaks and integration tests much earlier.
Yeah.
So yeah, I'm gonna share that
Okay.
in a second. But this is this is more in advance, and this is like where I'm heading. If well continuous integration can be done today, given the fact that we have an easier way to model dependencies between components, given the fact that we have containers technology that allows us to emulate staging much earlier. But you're hitting the right point of there are problems and there are challenges with this implementation.
It shouldn't be messy as a developer environment. That's one of the key of Docker, where if you rely on 5 containers, you can just say, I want to grade, and compose my environment based off those 5 services, and now you have them on the developer logs.
Yeah.
So the container is the dev environment?
It's a dev environment, it's a prod environment, it's every environment in between that you can really have a good traceability of what you do.
You can, in many cases, and I'm doing it myself, installing Docker on my machine and spin up multiple containers. Sometimes you want to share this environment with others and you want to spin it up in the cloud, but you can containers definitely make it easier for you to spin up a more complex application on your own machine. Okay, so I'll talk a little bit again, but we were just jumping ahead and we're talking about containers. When I'm still talking about the challenges with the continuous integration before containers. One of the first challenge that I want to talk about before containers, we talk about deliverables being the code base, is that when the deliverables are code, there is a high likelihood of having frictions between the different environments, between the development, what's running on the developer's machine, to the staging and production. Developers is making changes to his code, sometimes he's making changes also to environment variables, to other things that are installed on his machine, same for staging. It's not very clean, just the code, and when I'm just porting the code from one stage to the other, there is a likelihood of bugs to be found just because the environments are not the same environment. So this is one of the challenge with working with continuous integration before the era of containers. The other one is, I think you mentioned it earlier, is that there is a bottleneck. We're pushing all the very critical changes to happen only at a later stage of the life cycle. And in fact, what you see, the multipliers at the bottom, that's how much it costs us to fix an issue when it's found in the different stages. Obviously, the most expensive organization to fix an issue is when it's found in production, because it's very difficult now to go and fix that. If we find it in staging, it's also very expensive, because now staging is broken. No one can push changes into staging until we fix that issue. find it earlier in the build, it's cheaper, but obviously it's much easier when I'm finding these issues, when I'm still working on my feature branch. I haven't pushed my code anywhere. I'm just influenced, just myself being impacted and no one else in the team. So having most of the critical tests being tested only at the staging, that's a major bottleneck, especially if your team is not a single developer, but more than that. The other challenge that I want to share with you, which it's very common in almost every organization that I talk, is that, and even yesterday over dinner, it was mentioned, when there are requirements that are being gathered and then shared with the teams or with the engineers, they can be interpreted differently from one engineer to the other. They're not necessarily being implemented exactly the way we wanted. Now, a typical situation is that everyone, whether it's the product owner or the stakeholders, the first time they actually can see this feature implemented and can give any comment about this feature is when it gets into staging. And that is too late. There's almost no room to make and incorporate any changes when the first time that I'm seeing this feature and I can give comment is where it's the staging. Staging, developers already ready to push it out. I don't want to hold everyone back. I don't have time to make any changes now. And that's a major issues with an organization, because the requirements are not actually implemented the right way. And it takes me more iterations to get them to be implemented exactly the way the product owner or the customers ask. Make sense? Okay, so now is the time when I'm actually going to shift gear and tell you a little bit about what's the common de facto technologies that we're seeing out there, and how it help us in making this whole process of continuous integration much more efficient, much more predictable, and much faster. So I know you've been working with Docker a little bit. How many of you worked with Docker a little bit? Just run containers?
Not just a little, like Blinker was running on Docker.
Yeah.
Everything was the channel we have there, that's already deployed and put in place 2 years ago.
So, great. Docker is indeed one of the, one of the big reasons I left HB, and I left 3 years ago, a little bit less. And in fact, we see that, if I'm looking at our customers, both as, the default choice for startups as well as enterprises for new projects. For old project, the process of migration is not all the time an easy one. But when they're looking at a new project, it's much easier for them to look at Dockers.
Yeah, and I was, I'm not sure if I'll get the stat right, but I believe 60% of enterprises do have Docker, but it's not quite in production yet. So it's a much smaller number that has it in production, but the wave is kind of coming, and we were talking a little bit about this yesterday. Like, it will be everywhere, kind of running on your infrastructure.
So
and Docker says professional services, because just with Docker, your DevOps team, often they don't know how to push the prod. That's why there's CodeFresh. That's why there's other companies which augment that just the base open source stuff. Yeah. Which is it had challenges to put in production. Anyway.
So Docker. Okay, I'll start with the way.
Comparison between Docker and a VM, because a lot of people get those two confused. Yeah.
That's exactly
there you go.
Perfect.
Yeah, people want that.
Okay, so conceptually it's similar in a way that like the same way that VM image includes my application and everything that requires for the application to run. Containers also include my application and everything that my application needs to run. But with that saying, there's some fundamental changes between containers and images. From what you see in here, the way VM image, they have a hypervisor that actually emulate a full operating system as part of the image. Containers, there is a Docker engine and a daemon that actually manage all of these containers. And the outcome and the result is that containers are much lighter than VM images because they don't have all the operating system as part of it. Just as a comparison, a small VM, almost the smallest, can be 1.5 gig, while small containers can be 2.5 BusyBox, 2.5 megabyte. It's like much faster, it's much portable, and it can move. You know, another common comparison between VM image to a container that I've heard once is actually comparison between an apartment and a house. You know, if you think about it, you know, they're both intended to isolate strangers from coming inside my place, both the house and the apartment. However, for the house, it has to have its own plumbing. It has to have, you know, it's usually like a bigger size. It has to have a kitchen. It has to have like at least one room, one living room, and so on. It has everything on its own. While the apartments serve the very same purpose of keeping stranger outside, but they're sharing the plumbing with all the other containers. There are lots of things that are being shared with the other apartment. That's why it's very functional, and I can have a studio apartment if that's what I need. I can create a container just to what I need. It's not very common to find a studio house. House is usually coming with some of the things that I need and some of the things that I don't really need. Containers allows you to really build what is needed for your app and what it requires for it to run, and not much more than that. The concept itself is not a brand new concept. In fact, if we're looking at some of the Silicon Valley big companies like Google, they're running containers for many years by now. What Docker helped in increasing the awareness of standardizing the concept of Docker engine. And I will explain that Docker, in fact, when you look under the hood, there are multiple Docker technologies. When I'm referring here to Docker, I'm basically referring to the Docker engine and running Docker containers itself. Docker has other terms and tools that I will just say here so you're all familiar with. There is a concept of, I'll say just a common one, there's a concept of Docker registry, a place to store all the Docker images. There is the concept of Docker Compose, which is a format to define how multiple containers running together and a technology to spin them up all together. There's the concept of Docker Swarm, which is a way to orchestrate your application across multiple nodes, especially if you want to scale up your application. And then there are more than that, Docker Data Center and others, but that's I would say the main one that that you will need to know at least at this session. Now, the common one and the most adopted one is the concept of the Docker engine, running containers. How to orchestrate them in production. There are various other solutions that are popular too. The one that I think is the most popular is Kubernetes by Google. That's a very common way of running multiple containers across multiple nodes in your operation. Mesos is popular among the very large organizations, be it Uber, Twitter, and so on. And Docker Swarm is closing up some gaps with Kubernetes, but when I'm referring here to Docker as Docker, I'm referring to the very basic container unit that is common across all of these technologies. Now, the other part that is important to mention regarding Docker, it really makes microservices easier. It makes it easier to define the links between the different services. It makes it easier to spin up a more complex environment to just my application, and I'm going to show you that in the live demo. Lastly, we talked about the adoption of Docker. This is some of the stats about the number of projects and the growth of it. And being in DockerCon in Austin last week, I've seen that it's just the beginning. Most of the organizations are not yet in the process of having it in production, especially the enterprises. So this is just picking up. Although, just as a heads up, there is already technology built on top of containers that is even earlier in the adoption, which is called serverless or function as a service or Lambda. But I don't want to overwhelm you with too much of it. Let's keep it as simple as containers and microservices for now.
One thing on containers, it's really as old as mainframes, because IBM mainframes, for those who have been in that environment, had the same concept of running multiple isolated processes off a single OS kernel. And so a lot of the stuff that's been gathered from that has been dusted off and has been, obviously it's much more improved now, but
Yeah.
the concept is
And
nothing.
Solaris Zones was the same way. As this kind of came around, as Solaris was getting rid of zones, I went, huh, it's interesting.
There's,
The difference is that instead of paying $2 million, now I can spin out $100,000.
but even in Linux, there was the concept of C groups before this called Docker.
Yeah.
That you could do that. Again, Docker just make it, I would say, kind of democratizing the concept of containers to everyone, and we help. Cosmos is helping in that process. So it's really make it easier not only for DevOps experts to know things about containers. Developers can actually work out with containers as well in a much more easier fashion. So I want to talk a little bit about what's the values of container-based continuous integration and why it's changed a lot in the way we run continuous integration. The first part is that our build system can run every step in a container. Now, every step in a new container means that there is no leftover from previous build, and it's much easier to do that. When there is no leftover from previous build, I know I'm getting a very clean environment to start my build, and the chances of things to pass because things have been stayed there from the previous build, or things to fail because of leftovers is almost zero, because it's very easy to spin up a new build system in a new containers, clean from any leftovers, and run the build. So again, it just makes the stability of the build system much better. That's just from running the continuous integration inside containers. The other part is, I think, you mentioned that earlier, it just makes it easier for every engineer already in the level of his feature branch to get a running environment of everything else with his code changes. So I no longer need to wait for the staging to see if my code passed all of these tests. I can run all of these tests already here. I don't have to wait for the staging to share my code changes with all the other stakeholders. I can spin it up immediately, and I can send a link to everyone on my team. And we're doing it also with customers. I'm based out of Mountain View. I have my engineers in Israel. They can send me a link immediately of everything that they're working before they push into production. I can give comments, they can make changes, and then they can promote it to staging. It's much faster to incorporate changes.
And you also can look at more of a macro view, because typically when you're thinking at a code level and then you're deploying into an environment, now with Docker containers, you can actually version the whole image. So you may not only have your code, but you may have, let's say, things at an OS level that are sort of a configuration, and that's typically where things break, where my environment has X, but my code's the same as environment Y, but you turn a knob over here on Y that's slightly different. The container can encapsulate that, so you get that consistency, and then you can version that as an image.
I have slides, exactly. It's a great format. I can let you talk on that slide. That.
You want to hire me? Sorry.
So but that's okay. That's perfect. That's make the point even stronger. The other part, we talked about it. So not only that I can share, I can run all my tests and validations up front. Now there are certain things that, so when we're coming, there are certain tests that you still want to do in staging. Say for example, the staging is going to be very much like another step, but you don't have to hold everything to the staging. You want to minimize the errors that will be found in staging. For example, in staging, you're probably going to have an environment similar to what you have in productions with all the load balancers and so on, and you want to make sure that you are having running performance tests. You don't necessarily want to spin up the whole environment with load balancing and everything for testing integration tests to test the performance. We do allow and we do see running performance tests also here, but it's running it in a different way. We're not testing, when we're running performance tests in a smaller environment, we're not testing that we are meeting the number of concurrent user that we had in our requirement. But what we can test, we can test, if related to the previous build, if there is a degradation in performance or we're keeping it up. So we can track the trends of the performance, but we'll still have the staging to test if we're meeting, if you can hold the number of concurrent users that we should. And then, to your point, we're not passing anymore just the code base. I think what actually we are handing over to the production, we're handing over an image that includes not only the code but everything else that needs for this code to run. And the likelihood of this image to run in dev and not run in production the same way, I would say it's none, but it's almost none, because that's the same image and likely to work. And that works also on the way back. So it's very easy, and we've seen that when an issue or a defect was found, and a defect was found in that image, I can basically pull that image and see the code and see the defect. I don't need to kind of try, okay, so let me try to rebuild an environment with the same version of the code to see this defect. I can basically pull that image, run this environment, and find that image. And once we are actually, the core entity that we're passing all through the whole life cycle, if we do a handshake and image, it's a more of a self-contained unit, much more a complete description of our application than just the code base.
Yeah, another good example of that is a lot of times if you go to the Docker repository, how many times have people deployed an Apache or a Tomcat server or whatever? There are tons of reputable images of those. And typically what you can do, that can get you something up running instead of installing it, doing configurations. You basically instantiate an image to create a container. But then from there, if you want to add your secret sauce, for example, to your configurations, you can then go extend that image. We haven't even deployed our code yet, right? We're just trying to get our brand of common types of components like Apache, Tomcat, whatever. You can have that up and running. And then from within your business, if you have a standard way of how you want to deploy it, that can become kind of the baseline, the fact of here's how we do Apache web servers, and developers can quickly get a very consistent environment up. And at that point, we haven't even started with code yet, right? We're just getting kind of the infrastructure set up and standardized. So that's the other part that goes beyond the code for your environment.
Yeah. Okay. This is kind of more, now going back to the flow of the continuous integration. I can show you how, typical one in containers, what you want and you can implement. Whether it's with CodeForce, you can actually implement scripting that yourself. But this is what we've seen a lot of diagrams with our customers that's what they desired continuous integration they wanted to have. And we help them in implementing that. But if we're looking at it, we're saying that the first thing is that they wanted to have in every commit that the developer is going to his own feature branch to still have both the unit test and integration test running and so on. When he's making a PR, they also wanted to have an ability to spin up an environment before I merge it into the pull request, into the main branch, and test it manually, see how it works. And then once the PR is being approved, then that will trigger also pushing that image into the enterprise registry and actually deploy that to production. So actually, in the next step, when I like 8 minutes to show you a live demo of how this is working in CodeForce. Some of it again you can implement yourself, but just makes it easier. Any question before that?
I just want to add, for security reasons, that was, what you deploy, you can trace back to exactly how anything is built, and then you can run. What you were explaining is you can add in custom source. Basically, there are layers, so you start with a base layer, and on the Docker registry, you can see if this one has any known security vulnerabilities, and you can run it. So you know that, hey, my box is already secured, and you can run automated check to make it secured. And then you add all those different layers, so you can check at every layer you add to make sure that each of the layers is secure, and then you have full traceability also.
That's a great point. So in addition to kind of a better security posture inside, also when you look at a container versus a VM, from a security perspective, you have a massively reduced attack surface area. So I know, from security, SecOps people are really adopting containers just because it's a smaller attack footprint.
Right.
You gotta have people who know it, because you can also have a container that is fully open, and then you can go to the next container. So you have to make sure they're locked down, so that gets tricky. Maybe it's not the time for now, but that's where nano services, which have no layer, or just needed what you need to run your service, are more secure, because you cannot hack on the system, because there's no tools or command line to go to the next level. So,
Yeah, and there's a lot of issues around security containers anyway, which they're working out, but for enterprise, there are certain things that, lots of documentation on best practices to secure at the OS, so it's not a panacea. There are some actual real concerns around that, but I think that's gonna be worked out.
There are
But you need to be
concerns.
aware of that.
There are concerns around securities in general. Docker Swarm introduced some in the latest versions, some more security enhancement. There are also some open source projects to test security of containers, and some commercial companies like Aqua Security, Twistlock Security, and so on. That all they do is that, and we know that because we integrate with this platform, is one of the checks on the containers. You can pass, the Docker image, and they will test it. But you also brought up another concept that I will talk about, and I haven't mentioned it in the Docker conversation earlier. Docker image is built out of layers, which I think it's good that you mentioned that. There's always layers, and one of the benefits of having all these layers mechanism, as part of your build system, is that you can really leverage caching from one build to the others if the layers hasn't been changed. So building a new Docker image, if you haven't changed one of the very base layers, you can cache a lot of these layers and then just rebuild the layers that you need to build. So that's really I would say a great technology to accelerate the process of building. During the demo that I'll show you, the first build of the Docker image will take time, but the next build, actually all the layers are being cached, and it's going to be much faster. Okay, so what I'm going to show you a very, I'll start with the time constraint that we have here, showing you how to set up a very basic application on a new account. And then, I'm going to show you a little bit of a real life application. I'll show you how we run with it, which an application can be way more complex than this simple app. But for the simple app, I use a GitHub project. So here, when I log in into CodeFresh, I'll start by adding a pipeline for a simple project. This application that I'm adding, it's named Demo Chat. It's an open source, by the way, so you can play with it yourself.
So you can add a repo that's on Git.
That on GitHub, on Bitbucket, on Bitbucket Server, on GitHub Enterprise. Yeah, we integrate with all of that. So once I'm adding this repo, next, I can start, what would be the starting point to define the pipeline. In most cases, the repo that is using Docker has a Docker file. Docker file is a way to tell the Docker daemon how to build an image for that repository. So if you have that, you can select that as the starting point. If not, you can just simply choose the technology, and we will give you the default Docker file for that technology.
Was that YAML button for Docker Compose?
Sorry?
Was that for Docker Compose?
The YAML file, no, it's like we have, so I'll show you how to set up the pipeline in the UI, but most of our mature accounts are actually taking it from the UI, and they want to have a YAML file that describes the whole pipeline, all the steps in the repo. So I'll show that later on. So when I have a Docker file, you can see the Docker file here. That's a Docker file that is being used to build the image for that demo application that we're going to be using. To the point mentioned earlier, what the Docker daemon will do as it will build the Docker image for this repo, every line here is a layer. That's important to understand. What I meant by caching is that as it's going and it's building all of these layers, the first time it hits a layer that needs to be rebuilt, it will rebuild all the other layers. As long as it doesn't need to rebuild, it's just taking it from the caching. So that's how the caching mechanism in a very, very nutshell works in Docker. So I choose that Docker file, and then now as we speak, CodeFresh will start building a Docker image for that repo. In fact, we can go in and see the process of building the Docker image. And the first build might take time because we're actually going to build all the layers, pulling the layer of the Node.js in and start building all the layers for the application. While it does so, I'll show you a little bit the other parts of the platform. So the one place in which you define all the different pipelines for your repos. There is a place in which you can monitor all the builds. So whenever we're running a new build, we can see the build here and we can see the progress of the build. Here we will see all the images. So at this point we don't have any image yet, but we'll see here all the images we built, and we'll be able to run these images. We will be able to see additional metadata on this image. And what I mean by metadata is that in typical registry, and again we have an embedded registries and we connect to registry to remind us all registries where you store all the images. But in a typical registry, you see very basic metadata about this Docker image. Predominantly is the tags, or maybe a star that has on it. We enriching the Docker image with additional metadata, such as the unit test results, the integration test results, the functional test, comment that engineers can have, the Jira issue ticket that this Docker image was developed for. So it actually really helps you with seeing much more on this Docker image before you want to promote it to production. Composition, this is based on the Docker Compose forward. This is a way for you to define the dependencies between the different services. This composition can be used in two ways. One way is to get an on-demand environment that I want to share with everyone on my team. The other way is actually to be used as part of the pipeline, to say this step, when you get to that step, run all of the other microservices and then run my test, because my test cannot run against this microservice on its own.
Are you sitting on top of AWS for this?
So it's a good question. I'll show you the journey. Since we started the startup, we put our platform on AWS because they gave us $10,000 credit. Then Google came in and they gave us $100,000 credit. Now since we're running on containers, which is part of the benefit of container, we switched to Google. Okay. Then Amazon heard about us, Google, and they gave us another $90,000 credit because they want to move us back to Amazon. So we use them too. And now Azure gave us 100K. So I was on Azure. So we're really independent. So if you're running containers, that's part of the benefit. Unless you're running your containers on a very vendor-specific platform, such as ECS, which is the Amazon container, and if you're running it on top of Docker Swarm or Kubernetes, it's very easy to. You're not married to any one of the vendors. Obviously, it's easier, if you're working with S3 and everything on Amazon to stay on Amazon, but we are running now on Google Kubernetes engine, Google Container Engine, which is Kubernetes as a service. But the nodes that we spin up for our customers, we're leveraging all the clouds, including their own cloud. When they come into us and they say, I have my own infrastructure.
So you really
So their own cloud and Azure as well?
So yes, and as well. So they actually now have, we closed a large deal with a furniture company named Steelcase. I don't know if you're familiar with them. They have a large engagement with Azure. They're basically using us as the orchestration platform, but the nodes to run their builds and environment and so on are their own Azure nodes, so they can connect their nodes to CodeFresh, and basically, we manage these nodes, we manage the daemons on these nodes and everything else.
So you really have a hyper-cloud architecture, so you can move completely to one platform or break it up across different ones, and then use the generic components like Kubernetes, or do you use Spinnaker at all?
Sorry, sir?
Spinnaker?
I'm not
I
sure.
can take it offline, but so you're basically making yourself, like you said, agnostic, so that way you get the best of breed, the best of deal.
Exactly. So I'll start by creating a very simple composition here for this app. As I said, this is like a demo chat app. It has a Node.js web server, and it also needs to have a Mongo as part of it. So I'll create an add composition. I'll give it a name. And then if I have a Docker Compose, which in this case I have, but I'm not going to use it, I'll show you how Docker Compose look like. It's a file that is used to define the different services. So if I have that, I can use it, but I don't have to use it. I can basically go and say, let's create an empty composition, then I'll show you how it works. I can add my services, so I can add the service that I just added for the repo that I just added. This will auto-create for me a Docker Compose file. So we can see that here. I can add basically any image into this composition, including images from Docker Hub or from my own registry. So let's add Mongo. So I added Mongo. I can further define what's the port of my application. Again, what I'm showing you here, it's a very simplified. Expert, obviously, when you're engineers, you can just come to the edit. You can type in here what you want. If I would be able to move that, I will show you
Down
that
at the
there
bottom,
is.
there's a circle with the X behind those.
You can overlay it with encrypted credentials if your composition needs to connect to any other external services, being it S3 or SendGrid or anything else. You can encrypt credentials and have your composition. But now once we have defined this composition, let's see what we can do with that. So if we're going to go back to the build, so the build has been completed. If you're going to an image, we see an image here. At this point, again, the metadata for this image is very basic because we didn't do much with this image. We can see the commit info. We can see the Docker file that was used. We can see all the logs that were accumulated as we're building that image. Now, since I know this image is part of a composition, I can also come here and say, okay, I want to see how this image look like. I can choose run this image. I can run it either as a standalone or as part of the composition. When I choose it as part of the composition, what Codefresh will do now is basically spin up not only this image that we built, but actually spin up this image together with the Mongo image that has been defined in the composition.
So when you're building your composition, you mentioned services. Are those sort of synonymous with things like dependencies, volumes? You sort of abstract that as
Yes.
a concept of a
Yes.
service, and then those get thrown into the Docker composition.
Yes, so these are also, so it's good that you mentioned volumes are being extensively used here, both as part of the composition, also as part of the pipeline. So as you define the pipeline and you define multiple steps in the pipeline, all the steps are sharing volumes, and you can define additional volumes. So you can have the output of one steps be the input for the next steps. This is like really an advanced questions. I can show you that later, but definitely yes.
But you're making that whole thing that you used to do by hand through a GUI and giving kind of a high-level tool set and interface.
Yeah. Yes,
configure
yes.
that.
So it really makes it easier. So everyone now can actually go use it. You can still get to that sophistication level in our YAML file and make things that are way more complex, and I'll show you how it works. But it's how easy it was now to get a running environment. You can click on that here. There is a demo chat application now running. If I'm going to go to the environment itself, we can in fact see that we have spin up an environment here. There are 2 containers running as part of this environment. This is what running in each one of these containers. So it was very basic, very easy for me to spin up this application. Now I can go to the pipeline and hear what teams are getting interesting. When I'm getting to the pipeline, I can add some tests here. So I can say gulp test. That's my unit test. But even if this unit test requires a composition, I can come to that step and say, run it with a composition, choose the composition that I want to run together with that steps, and then I can tell it, and then run my test inside this container. And then when I'm going to click on the build again, now it will actually also add another step after the building the Docker image. In this case, it will not really build the Docker image because it will see that nothing in the code has been changed. So it's basically going to pull that layers, see that there is nothing to build, and it just move to the next step. So it's here, see that there is no need to build, it's running unit test. But when it's running the unit test, it's actually creating an on-demand sort of a staging environment, running the unit test, it does the very same thing for integration test, and then turn off that environment. And that actually really helps me in parallelizing, running more sophisticated tests.
So this is an orchestration engine to pull all those pieces in
Yeah.
to run your CI and CD.
Yeah, so it pulled up all this, all the images, it spin up here an environment. And now the interesting part is now when I go to this image, as I show you, that's just the beginning, There is additional data now about this, like the test results and so on, that we can see. Now let me show you one more thing before I'll open it to questions, because we're also running out of time. So I'll show you one more thing here. This is how things are getting way more complicated. This is our own platform. Obviously, we're eating our own dog food. There's way more services that we're running in our backend to run CodeFresh. You can see that we, in fact, do not necessarily run and specify all the steps here. They're all being specified as part of a YAML file. You can see that the YAML file can have multiple steps. Some of the steps actually require us to spin up the whole composition and then run the integration test. Our composition, to the point, we can see all the builds here. Some of the builds run, some of them are failed. So again, this is a live system, there is a failed build. You can see that composition can be a way more complex than the composition that I shared with you earlier. But that's how how the whole application is being modeled. But then it really makes it easier for everyone in the organization. And you can see that when you're running tests, you can actually see that this image was tested. So there is like an indication this image passed all of these tests. So I'm not promoting images that haven't been tested. But at any point of time, you can see these are different images on different branches, which means developers are working. At any point of time, if one of them want to share with me the code changes that he's working in, he can come to any one of these images and say, okay, so run this part of CodeFresh pool. And now, in fact, as we speak, I'm spinning up now a whole new instance of CodeFresh itself, but with this specific image in place. So that's a way for us to get an on-demand environment, but very fast, and I can share it with the rest of the team. So it's going to take under 1 minute, sometimes even faster than that, to get a whole new environment, and I can see how it works. I can share, I can get feedback and so on.
So can I, for example, I can version my source code, I can version my images, I assume I can version my composition, so it's hierarchy. So if I've got all of, for example, those 3 components that create version X of my thing, I can encapsulate that in my composition, which then points to GitHub or wherever my repository for images, and then it just goes, builds it and deploys it. Is that the pipeline?
Yeah. So the pipeline is a series of steps that happen, that triggers each time your code is being changed. Some of these steps can be very basic steps, especially if you're working in Java, like just compile the code. Some of these steps can be, okay, take all the compiled attributes and build an image. Some of these steps can be, take this image now, this is how our application needs to run. Create that environment, run the test, and some of the steps can be, take that image now and deploy it to Kubernetes or deploy it to Swarm or to my production. You can set each one of these steps, whether these steps run on all the branches or only on individual branch. So you can say, okay, so this step of deployment, run it only on master or only on develop. You can also set attribute on steps, saying these steps, if it fails, fail the whole build. Or even if it fails, continue, don't stop the build. So you have that flexibility that all can be modeled in a YAML file, which is much more robust than our UI. Our UI provides very 4 basic steps, deploy, integration, and so on. And in this YAML file, you can basically have all of these dependencies.
All the pointers to what
Yes, all the pointers you mentioned. Yes.
Can you do things like Terraform? Are you familiar with Terraform?
I'm not familiar with that.
So it would be called CloudFormation in AWS. So what these are, infrastructure as code. So in this case, it's actually quite powerful when you add it with this, because in many cases we talk about containers being able to encapsulate that. But then say you want to go into performance testing and you want to configure load balancers with testers, you want to set up subnets, you want to do all the things that you would start from scratch if you're building in production. Terraform is cross cloud, and it's essentially a YAML file where you get to configure those. So if you grab that with what you have, you can go from 0 of no environment at all to completely configured network, load balancers, all that stuff, servers, you name it, and
So-
you can kind of build the whole 9 yards from that.
So basically, if the engine to run this can run inside an image,
Yes.
that can be easy because it's run on Linux. That can basically be part of it because every step of this pipeline is running an image. So basically, you can get to a step and say, bring me that image.
You're there.
That image can be kubectl to run Kubernetes, or can be gcloud to run. So bring me that image. This image, when you run it, it's already part of the same volume for with everything else. So you can pull that image. You can do everything you want as part of this pipeline, as long as it can run inside a Docker image.
Yeah, because if you look at CloudFormation, it's just like a Docker
Yeah.
Compose, except within that you actually have a section that's actually doing your images and your networking and everything else.
Yeah.
So that would be a superset of
Yeah,
what you're
yeah,
just talking
yeah.
about.
So here, you know what I saw, like it took 29 seconds, and there is a new version here of CodeFresh running. And if I go to this environment, we can see that, where is me here? I just spawned up this whole new environment. These are running all the branches from develop, but this image that is running my old code changes. I got it like up and running very fast. I can open the link, send to the team. I can Slack. I can actually go and add a Slack message and Slack this environment and they can go check my feature and how it works. It's basically how fast it is to collaborate around images till the deployment.
So is your tool, like if I'm a business, so obviously you're trying to sell a service here, am I using this as like a proxy to, let's say, Google or Amazon? So let's say I'm in AWS and maybe I'm a hyper cloud type person where I have stuff all over the place.
Mhm.
Do I use this as in or on-premise, in the cloud or on-premise to be able to orchestrate those things? Is that the product I'm looking at?
You're using it, so CodeFresh is a software as a service. It's
Okay.
subscription based. Again, what I did here, you can write a lot of scripts and implement it yourself on top of it. It's going to take more time in maintaining it. But basically, it's a software as a service built for containers. You can plug it to your code base, and then you can set pipelines that will be triggered whenever you make your code changes, and that will test the code and deploy it to your
Environment, okay, so
environment.
this can push as long as I set up the right permissions
yes.
and right services. So
Yes.
I use this as a SaaS to manage my cloud/container environment.
Yeah.
Okay, cool.
Yeah, that's very cool.
It's called Fresh Open Source.
Not yet.
Do you want to go there? or-
Yes, you want to go there. You want to go there. There are a few things, you know, on our roadmap that are coming up. First of all is local executable, so you can also run it on your own and not only as part of our service. You can in fact do that because as long as you have a Kubernetes cluster, we can, you know, keep the images and you can provision it yourself on your Kubernetes cluster. But we also plan to open source at least the component of the running the pipeline. Any?
I mentioned Spinnaker, which is a Netflix open source.
Yeah.
It's actually, you should probably take a look at it. It's pretty cool because one of the big features, it's sort of like a superset of Kubernetes. I mean, it sits on top. So we're having all these layers, right? We started with containers, we encapsulate with Kubernetes, and we're building stuff on top of it. What Netflix uses it for a lot is, obviously they have a huge CDN type network where they're distributing a large amount of content all around the planet. And what Spinnaker does is it really kind of streamlines what they call pipelines to take the source of whatever you're building, and then and it's based on Jenkins, but it can work with, I think, Bamboo as well, which is Atlassian's tool. And you can do your continuous integration deployment, everything that you've done there, but it sort of streamlines the ability of where, say you're building a multi-geo or multi-hyper cloud, or you just have one environment, doesn't matter, it actually can branch out and distribute your app and all the components, including like the Terraform example, and it can go enterprise really, and it's open source and it's free.
So what Netflix are doing, I think now I can recall, what they do, it's called canary testing.
Canary testing.
Canary testing, which is basically saying, I'm doing some of the tests not really the staging, but actually doing that on a subset of my production. I expose this feature to subset of the production. And if that goes well, I can actually open it and let the whole organization. So that's an additional level of testing that that I introduced, which actually, it's getting more and more popular.
Yeah, Spinnaker's kind of similar to what you're doing, except you're kind of making it more user friendly than what
Yeah.
Spinnaker's a little bit more cryptic. Very cool.
Thank you. Okay.
All right. Great job. I know for some of us with, kind of different levels of familiarity, we have the recording, so you could run through it a couple of times. I would like to understand, maybe pricing, and then, kind of access if folks want to try it on their own.
Good question. So basically, the way CodeFresh works and the various options there. So there is the option that is fully SaaS, which basically says you create an account with CodeFresh. If you open source, it doesn't cost anything. You can basically run your builds with no cost. If you have your private repo, which is not open source, there's different levels of pricing. Depends on if you want to have your own dedicated nodes and how many nodes you want us to run for you. It starts from $99 a month, and it goes to $299 if you have a private node for yourself. Then for every additional node you pay more. If you already have an AWS account and you want to leverage your own infrastructure, you can basically come to the account management, and I'll show you that. And you can basically go to nodes, and you can add your own nodes. So basically, then you're just going to pay smaller amounts for managing these nodes, but you're going to leverage your own resources to run the builds and environment. So then there is both this hybrid and fully SaaS mode. If you don't want to deal with any kind of adding nodes, you want CodeFresh to manage all of your nodes, you can add nodes from us. If you already have your infrastructure, you can add your nodes to CodeFresh. The thing that now we're working with the larger accounts is actually they're getting the full on-premise versions of CodeFresh to their infrastructure. And the reason they need the enterprise is for enterprise features, they can actually create multiple accounts within their organization. They can allocate nodes to accounts or to business units. So if they want to restrict certain nodes or resources to one business unit versus the other, they can do that with the business, with the enterprise of CodeFresh. But for small teams, it's very easy to go to CodeFresh.io, sign in with GitHub, or with Bitbucket, get an account and start working.
So your customers that are using this, I would assume this is probably really good for companies that are fairly new to this but want to take advantage of it. This helps streamline and shorten the learning curve. Is that true, probably?
So we see, to talk about cognitive integration, but I can talk about our customers too. We see two main type of scenarios. One of them is medium-sized companies or startups. They want to get up and running. They don't want to hire, an expensive DevOps full-time. Sometimes they take a service of a DevOps, but we have some DevOps that are giving services actually introducing us, but they want to get up and running on containers very fast. They're using us, and we orchestrate the whole building and deployment. We also have large organizations that have already made a decision to move into Docker containers, and in the process that they came up with a model, but then they said we either get 2 release managers or 2 DevOps people to script a lot to make it happen on top of Jenkins, most likely, which can get them closer to what we offer, but also create something that I need to maintain, like a homegrown solution, and that is also not as open to the other team members. It's basically the one who knows how to orchestrate. This is a DevOps person that knows all the script in Jenkins. And this is in fact not only that it gives them out of the box, this one thing, it's also democratized the usage of containers and spin-up environment. for the rest of the team, whether you know images and composition and everything or not. It's very easy to benefit from components. So it's both on the enterprise level, helping them with the migration to containers and adoption internally of containers, as well as startups that not necessarily can afford having a DevOps person as part of the team and want to get up and running very fast.
So I assume you can put some form of gatekeeping and security. So for example, let's say I allow free reign Wild West to a dev and limited more for staging, and then I have a very more constrained set of best practices to go into production, and I drank the Kool-Aid on this platform. Can I add access control lists or some sort of restrictions so that only certain individuals or whoever they are roles can only push the button and deploy into production through this? Or is it? Not yet there.
Okay. You can say that certain things are going to happen only on certain branches, and there's roles of admin and users, but we haven't expanded the roles and permissions.
Okay.
But it's not on the roadmap, but not there yet.
Okay, good.
So on the other end of the spectrum, I'm gonna ask a really basic question.
Yeah.
So if I have like ground infrastructure, basically I just have to have the Docker engine installed like in a VM somewhere, or the Docker engine installed in public cloud, and then I can address that with CodeFresh?
You don't even need to have a Docker installed. You know, if you want to add your nodes, you just run a script, and that's part of the benefit is that we're going to provision what is needed there to run the containers and to build the containers. We're also going to be cleaning that, because you know, if you did it yourself manually, you'll find out that Docker is a great technology, but it's not free of bugs. You get a lot of sometimes the zombie containers that needs to be cleaned. A lot of things that are being stacked, and basically when we manage these nodes, not only that we provision what needed there to build containers and run containers, we also monitor, put the latest versions of Docker there, see that the daemon is in a healthy state, and restart it if not.
So how would you deploy a node in like a ground infrastructure?
What do you mean by that?
Like, okay, so if I don't need to install like the Docker engine on like a server in a data center or a VM in a data center, what do I need to do to run CodeFresh on top of it?
On top of your nodes,
Yeah.
there is a script. It's also in the document. There's a script that you will have to run on that machine,
Yeah.
and that will connect it to CodeFresh.
Okay.
So
And is that the same for EC2 instances?
the same.
Okay, so you run it,
Yeah.
then it connects
You
to
need
CodeFresh.
to have,
and
you
then
need to
can
have
go-
obviously a connection, a network connection between them.
Okay.
If not, we set a VPN, but basically you run a script, and the team actually can help with that. So we're running Intercom, which is connected directly to the Slack team. So when you come into CodeFresh, at any point of time there is a chat here at the bottom, also for the product. For any questions you can ask. The whole team is getting these questions right away to the mobile. Sometimes we're just testing it to see them clear. But that's a way to really get all your question answers in addition to the communication.
And are people on Slack like 24/7, or do you have like
we have
some hours?
we have people on Slacks. We have people for enterprise. We have 24/7 support. Yeah.
So one of the advantages, in my opinion, of Kubernetes, let's say like a typical Docker swarm, is pertaining to microservices. So those that are not familiar, there's a huge concept of service discovery, which there's various ways of doing that, where you have a distributed set of services, and how do you discover that particular service. And one of the things that Kubernetes does is, if you were to say, let's say, encapsulate a service per container as an example, to make it a simple example, how do you go discover that service? And one of the things that Kubernetes does is it helps make it simple in terms of a highly distributed microservice environment. So my question is, are you having features or things that help those that are building, because this is sort of generic containers, not to a specific architecture framework, although it does enable microservices. Do you plan to add more features to that where if I'm really gonna build like that distributed environment of multiple containers that need to talk to each other,
Yeah.
that you can help enable that through best practices, whether it's Kubernetes, whatever, so it's
Yeah.
seamless. That
So
makes sense?
Yeah, that makes sense. So there are lots of documentation and best practices and the things that we are helping with discovery. There is also steps that have been kind of template steps for the different technologies, so that helps you know if I go even show you here.
Like you've got, was it Eureka, which is one of the ones that Netflix uses for.
There's some steps that are and we adding more and more templates. You see it here, especially on the deployments. Deploy images to the different technologies, whether it's to Swarm or to ECS or to Kubernetes. You can really like use that, and that really can help you with doing that. In addition to that, you know, both Kubernetes and Compose, there's certain ways that they are exposing you to other services. So in Kubernetes, and I'm sorry if I'm getting a little bit, Kubernetes actually every container is running in what's being called pod, and in Swarm it's still in the container, but every pod has both environment variables that tell me about the other services in the URL, and there's also a DNS that can be by default service that's going to be there. Similar approach is also in Docker Compose when it's put in your etc host, all the other services that are running with this Compose with the URL. It can get a little bit more sophisticated, it can get way more sophisticated than that. But you know, we have a documentation showing you how to do all that. Sometimes we also give you what's the external URL that you have for your application, so you can use that also as part of your automation.
Yeah, like for example, I've used Kubernetes like with Redis, which you can set as a cluster, and all you really have to do is define, you don't care what the IP address is,
Yeah.
whatever, you configure, you call it Redis, and magic happens in terms of finding your Redis cluster where the other ones, it's a little trickier. So that to me, having that type of feature when you start taking all of these containers and trying to make them kind of more seamless and integrated, especially on a microservice architecture, it's a lot of headaches around, one of the principles of microservices is around discovery, right? To make that a lot easier with containers.
You can build fairly complex ecosystem by just conventional configuration, and then you just each service know by name like API dot something, and then just with DNS resolution, that's your discovery. So you don't have to build stuff to auto-discover. You just say, you name the convention of how the services connect together, and then everything works kind of.
Yeah, that's what Eureka does essentially. It does
In the demo, so in the demo chat app that I show you, the way I refer to the Mongo is just by saying, you know, calling it Mongo. And Docker Compose is making sure that this Mongo is being translated to the IP that's been allocated to that pod. Obviously, you know, in Kubernetes you can do that. You can do that multiple times on the very same cluster using namespace. So you can also isolate different namespace and use the very same one within that namespace.
Okay.
To create multiple environments. Yeah.
Okay,
Okay.
we're at time, unfortunately.